Hey guys, we're going to go over the Unit 5 test review. I know the paper says Unit 6, it's really the Unit 5. Alright. Describe the end behavior of the graph of the polynomial function using infinity notation. Alright, it gives us this function, okay? So you just got to remember the first question what's asking is saying, what is y doing as x goes to the left, and what is y doing as x goes to the right? Remember, we can look at the degree, okay? The highest degree is 4. That's even. Even degree, okay? If you have an even degree and the fact that it's negative. Okay, so once again, even degree and negative coefficient on that. Therefore, it is down and down. So y is going down both times. How do I say down? Negative infinity, negative infinity. All right? All right, number 2 is the same question. I don't feel like rewriting all this. So we're going to use the same answer selection on number 2, okay? The highest degree on number 2 is 11. It is positive. So odd, positive, down, up. So y goes down to the left, and it goes up to the right. There you go. That's how you do 1 and 2. All right, let's go to 4. All right, problem number 4 says, oh, I didn't mean to do that. Problem number 4 says, solve each polynomial, find the zeros. Okay, look. We could do this several ways, but the fact that we're gearing them for a unit test, I want to do this the easy way. Alright, so first off, you could do this through synthetic division, okay? In this problem, you legitimately could do P over Q. You could list out all the possible P's, which is 12, all the factors of 12 divided by Q, which would be all the factors of 1. So that'd be plus or minus 1, 2, 3, 4, 6, and 12. You could do that. And then you could just start checking the different ones through synthetic division until you find the ones that worked. However, I'm going to cheat. I'm going to use a calculator, okay? So I'm going to pull up my calculator. Because what are zeros really? X-intercepts. So we go to y equals, and we say x raised to the third minus x squared minus 8x plus 12. Whoa, 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 I said plus 2. And I'm going to work to make sure you guys get calculators either today or definitely by our test tomorrow. Alright, I'm going to hit graph, 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 any day now. There we go. Okay, now you should say, oh, okay, here are 3 zeros. Now, some of you might be like, wait, that's only 1 0, Mr. Miller. What do you mean 3 zeros total? Because you got 1 here, but I only see 1 there. Well, when it bounces up like a parabola, how many times is that 0 happening? 2 times. So I really have 3 zeros here, okay? So let's go to the table and see if I can't find them real fast. Okay, I have the 0 of 2, and that looks like to where my parabola is happening. So that means I have 2 is happening actually 2 times. And then I also have the 0 of, it looks like I have a negative 1, negative 3. So my zeros for this problem are negative 3 and 2, but 2 has a multiplicity of 2. Okay? Let's go to problem number 5. P of x equals x to the 4th minus 7x squared plus 6x. Once again, guys, you could do the possible zeros, and then you could just start checking through synthetic division. Again, though, for the sake of time, I'm going to cheat, alright? Because I can. I'm going to go to y equals, click clear, I'm going to say x raised to the 4th minus 7x squared. And this isn't actually cheating, it's just a shortcut. Alright, it's just not as much algebra. Second graph, oh, I hit second graph, I meant to hit graph. Okay, so first off, I have a degree of 4, so I know I should end up with 4 zeros. 1, 2, 3, 4. Hey, it looks like they're all, so now let's see if they're all nice whole numbers that I can find just by looking right here. Alright, I have 1 at negative 3, 1 at 0, 1 at 1, and 1 at 2. So my zeros are negative 3, 0, 1, and none of them have multiplicities greater than 1. And you can see that when you go back and look at the graph, I cross through like a line, I cross through like a line, I cross through like a line, and I cross through like a line. So each time I touch the x-axis, I cross through like a line, so that means I have a multiplicity of 1 for each one of those. Okay? Let's go to problem 6. Same kind of idea. We're just kind of making sure we understand how to do it, so we're just repeating it several times. Comes up a lot in your test, so you want to make sure you know how to do it. It's one of those things that we ask a lot of questions on. Minus 15x squared plus 27x minus 10. Hit graph. I have a degree of 3, so I want 3 zeros. 1, 2, 3. And it all looks like they go through like lines. That means they all have multiplicities of 1. So it looks like I have a 0 at 2, a 0 at 5, and it looks like I'm missing my third one. Oh, hold on. We may have to do a little bit of extra work. Okay. That looks like 2. Let's hit trace and just see. It looks like we might have a 0 of 0.5. But you know what we can do? We can check that through synthetic division. Alright? So, because I'm not entirely sure, it could be something like 0.6. It's not necessarily 0.5. So what we're going to do is we're going to say 1/2, and I'm going to draw my upside down synthetic division box, to -15. Now, there's also a calculator function you could use, but I kind of want to make sure we get a little synthetic division practice. Okay, down your 2. 1/2 times 2 is 1. -15 plus 1 is -14. 1/2 times -14 is -7. -27 plus -7. I'm sorry. 27 plus -7 is 20. 1/2 times 20 is 10. And I got 0. Sweet! So then I know that 1/2 is one of my zeros. 1/2 is one of my zeros. And then I saw my other two. It was 2 and 5. So I don't need to check those through synthetic division. I know for sure that I got those. Bam! That's what I'm looking for. That's all she wrote. Alright? Next problem. Problem number 7. Describe the transformations used to change 1 over x to 7 over x plus 3 plus 2. Okay. We talked about transformations for like 3 weeks, just never specifically with the rational function. Okay. Remember, transformations tells me how my graph moves. It goes up, down, left, right, stretches, shrinks, stretches, shrinks. Alright? So first off, we have a plus 3 with the x. That's left 3. Okay? That is a left 3. And then we have a plus 2 outside the function. That means up 2. The last thing that changed is this 1 became a 7. How did that happen? I multiplied by 7. Because 1 times 7 is 7, right? So I multiplied this whole function by 7. And that just multiplied the 1. Because, that's how you multiply fractions. Whole numbers to fractions, you multiply the top. Alright? So then that is a vertical stretch by 7. Okay? Alright, number 8. Determine all the discontinuities, asymptotes, of the function. Alright, so let's find all the asymptotes. First one I want to find. Oh, this is kind of a cheating problem. We haven't really discussed this, but you do have to think through it. Alright, so first off, we have a horizontal asymptote. Alright, remember, horizontal goes this way, left to right. Okay? But we look at the degrees. Well, there is no degree on top. There's a degree of 1 in the denominator, so that means we're bottom heavy, right? So right now you want to say it's y equals 0, because when you're bottom heavy, it's y equals 0. Except this minus 3 does some stuff. This minus 3 is going to take us from being, just like that at y equals 0 down 3. So it's going to move us to y equals -3. Okay? Alright, next thing I need to find is my vertical asymptote. Alright, set your denominator equal to 0. That's just x minus 2. Add 2 over, you get x equals 2. Bam. There's vertical asymptote. There is no removable discontinuity because there's nothing for me to factor and cancel out. So those are the only 2 asymptotes. Oh, and there's no slant asymptote because to get slant asymptote, you have to be top heavy. Alright, let's go on. Number 9, name and describe the x-intercepts, vertical asymptotes, and horizontal asymptotes. Alright, so I'm going to start off finding horizontal asymptotes. Alright, horizontal asymptotes. Alright, so to find horizontal asymptote, we look at the degree. the degree of the top is 1, the degree of the bottom is 2. We're bottom heavy, so the horizontal asymptote is y equals 0. Alright? Next thing I need to do is to factor the denominator and see if I can cancel out anything. The answer is going to be no, but I'm still going to factor the denominator. Alright? So I draw myself a tic-tac-toe box. This is how I factor. However you factor is different. That's okay. X squared, 3, 3x squared. I need to add up to 4x, so I need two numbers that multiply to 3x squared, but add up to 4x, so that gives me 3x and x. X squared, 3x, what do they have in common? An x. X squared, x, what do they have in common? An x. X times what is 3x? 3. X times what is x? 1. So we go across, we go across. So this can become x plus 3, x plus 1. Alright. And so now we're here. We have x minus 2 on top. We have x plus 3, x plus 1 on bottom. Nothing to cancel. So my vertical asymptotes, I set both of those denominator pieces equal to 0. So, you say x plus 3. Oh, that's a weird x. X plus 3 equals 0. That's a 3. It's just getting bad. Alright, subtract the 3 over and we get x equals negative 3. Okay, so that's our first asymptote. Now set the other thing equal to 0, the other piece. That's a comma right there, by the way. Alright, set x plus 1 equal to 0. I feel like I was getting monotone. Subtract 1, we get x equals negative 1. So we put that in. Bam! There's our two vertical asymptotes. To get your x-intercept, you set the To get your x-intercepts, you set the numerator equal to 0. The numerator is x minus 2. You set that equals 0. Add 2, and you get x equals 2. So your x-intercept is the point 2, 0. Alright? Alright. Number 10. Same question, just different problem. First off, the horizontal asymptote is pretty easy. It's the degree on the top is 1, the degree on the bottom is 2. So it's it's bottom heavy, so once again it's y equals 0. Alright, next thing is I like to factor my denominator. So, good practice for those of you that are still struggling with factoring. We put x squared, we put negative 12, we get negative 12x squared. This is kind of hard to see with this bright green like this. Let's change colors. Alright, I need to find two numbers that multiply negative 12x squared but add negative x. I think, and I realize, oh, I'm a dummy with a tummy. It's negative 4x and 3x. X squared, negative 4x, what do they have in common? X. X squared, 3x, what do they have in common? X. X times what is negative 4x? Negative 4. X times what is 3x? 3. Go across, and this becomes x minus 4, x plus 3. And that cannot cancel out anything on top. So that means now I have two vertical asymptotes. Set your denominators equal to 0 to get them. So you say x minus 4 equals 0. And you're going to have to add 4, so you get x equals 4. Alright. That's your first vertical asymptote. Now you set x plus 3 equals 0. Alright. You subtract 3, you get x equals negative 3. That's your second vertical asymptote. Alright, and then to get our x-intercepts, we set our numerator equal to 0. Okay, so if you set 2x equal to 0, set 2x equals 0, then we divide by 2. We're going to get x equals, 0 divided by 2 is 0. So we get the point 0, 0. Boom shakalaka. Alright, let's go on to number 11. Alright, number 11. What is the difference between a removable discontinuity and an asymptote in a rational equation? Okay. Simply, removable discontinuity, I cannot spell today, discontinuity, has a factor both in the numerator, and in the denominator. Vertical asymptote only has that factor in the denominator. Basically, guys, all the differences is that to have a removable discontinuity, you have to have that factor, that RD factor, in both the numerator and in the denominator. Whereas to have a vertical asymptote, that RVA factor does not exist in the denominator. Like a quick example, since we haven't done one yet, would be something like if you have an x plus 3, that's a weird 3, but I promise you I meant to be 3, over x plus 3 times x plus 5. Okay? Well, you see I have a removable discontinuity at x plus 3 because it's in both the numerator and the denominator. But I have a vertical asymptote at x plus 5 because that's not in the numerator. Alright? And you can word your answer however you want, but that's just the basic idea you need to get across. Okay? Let's go back up. I put this weird on the PDF. It's backwards. Alright, find the coordinates of a removable discontinuity. So that means we got to factor everything. Alright? Hopefully y'all are good at factoring now. X squared minus 9 becomes x plus 3, x minus 3. That's called the difference of squares. Over x squared minus 7x plus 12. This is becomes x minus 4, x minus 3. Okay? And so you see I have an x minus 3 over an x minus 3. So those two cancel. So my new equation is just x plus 3 over x minus 4. So I take my x minus 3, because that's what I canceled out. I set that equals 0. I add 3. So now x equals 3. I take this 3, so that's the x value of the removable discontinuity. To get the y value, I take this 3 and I plug it back into my new equation. So that would be 3 plus 3 over 3 minus 4. Alright, so that gives me 6 over negative 1, which is just negative 6. Okay? Alright, so my removable discontinuity is at the point 3, comma, negative 6. Okay? Alright, moving on. Now, these next two questions are not things that we specifically covered for like a day in class, but we've covered all the ideas for it. Okay? So don't be alarmed about them. Just think through them. Alright? It says, describe the behavior around the vertical asymptotes of each function. Okay, so first off, guys, we talked about describing behavior. All that we're worried about is what is y doing, what is y doing on the left side as we approach, and what is y doing on the right side as we approach. Okay? It's not hard. Now, but just instead of looking at the left side going forever like this and the right side going forever like this, I'm just looking at the vertical asymptote. So I just want to know what is y doing as I get closer on the left, and what is y doing as I get closer on the right. All right? So first off, what is the vertical asymptote? Negative 6. Very good. The vertical asymptote for 13 is negative 6. Okay. Now don't be alarmed about this question. You're just gonna have to think through it. All right. That purple's just getting in the way. X equals negative 6. Okay. So I'm gonna make sure you guys have graphing calculus for the test tomorrow. Okay. So negative 4 divided by x plus 6. Hit graph. Okay, so let's just look at the graph. Don't freak out about this question. Just look at the graph. Here's your asymptote. What is y doing as I come in from the left? Y is going up. What is y doing as I come in from the right? Y is going down. So, here's how we write this question. As x approaches, as x approaches negative 6, okay, from the left. Oh, my calculator's going to get in the way now. From the left. From the left. What is y doing? That's the question. What is y doing? F of x approaches what? Well, look at this. As I look at it from the left side, the graph goes up forever. So that'd be infinity. Okay, now we're going to ask the same question. But instead of as x approaches negative 6 from the right, what is f of x doing? In other words, what is y doing? We'll look at the graph. What is y doing? Y is going down. So that's negative infinity. Bam! That's our answer. That's all it wants. Describe the behavior around the vertical asymptote. That's all it wants you to do. Now, this may seem like a silly thing to you, but it's actually an important calculus topic, all right? A lot of the stuff we're doing right now comes into play in calculus, all right, about limits and derivatives. So it is an important topic, all right? But it's not something we need to spend a day on, guys, because just look at the graph and look at it as approaches from the left side as approaches from the right side. What is y doing? That's the whole question. All right, let's go to 14. First off, what is my vertical asymptote? Well, you said x squared equals 0, you get x equals 0. So my vertical asymptote is x equals 0, okay? So just because this could be worded slightly differently, we could also say f of x approaches what? I'm trying to make this a little bit neater, so instead of me writing, I'm trying to type it. As x approaches 0, from the left. Okay? So let's look at this graph. Let's plug it in. So the graph is negative. I'm going to move this over here to get to that negative. Negative 2 divided by x squared. Big graph. Okay? So here's my vertical asymptote at x equals 0. So what is the graph doing as I approach it from the left side? The graph is going down towards negative infinity. So I can say that y is approaching negative infinity. Now we're going to ask the exact same question, but instead we're going to look at it from the right. So f of x approaches what? Okay. F of x approaches what as x approaches 0 from the right. Okay, so we just need to look and see what is f of x approaching. Oh, I clicked the wrong button. There we go. Well, as I look at the vertical asymptote from the right side, coming to it from the right side, what does it look like y is going towards? Negative infinity. So once again, I would say negative infinity. Bam! That's our answer. That's all you have to do on this one, okay? I know a lot of y'all are going to freak out about it, but it's really not meant to be hard. Let's try 15. Solve each inequality. This is what we've been doing. This is just where we need to list our zeros. Oh, no. First off, let me tell you. Do not worry about problem 18. We don't do that one. Okay? So, this is just where we need to list our zeros and our vertical asymptotes, make our number lines, and we're ready to rock and roll. So first off, number 15 doesn't have any vertical asymptotes. It just has zeros. So you say each one of these pieces equal to 0. So you get the zeros of 0, negative 6, and negative 1. Now we're going to make our number line. We put that on there. So negative 6, negative 1, and 0. So then we need to pick numbers to the left of negative 6, numbers between negative 6 and negative 1, numbers between negative 1 and 0, and then number to the right of 0. And all we need to see is if it's either positive or negative. So we pick a number to the left of negative 6, such as negative 7. Okay, we need to plug that in to our equation. So negative 7, okay, and some of you guys, I've had several of you come to me and say, you're just not seeing how to multiply stuff the way I do and talk about positive. So just cheat and use a calculator. It's not cheating. I don't know why I keep saying cheat. It's really genuinely not cheating. Okay? So we're just going to plug in negative 7. To me, it just takes a little bit longer. It's faster to do in your head. But there's absolutely nothing wrong to use your calculator either. So then it gives us negative 7 plus 1. And we get negative 42. So that means that all y values to the left of x values of negative 6, that means all the y values created by x values that are to the left of negative 6, those x values create negative y values every single time. So even if I had chosen an x value of negative 8, it would have given me a negative y value. If I had chosen an x value of negative 9, it would have given me a negative y value. If I had chosen an x value of negative 100, it would have given me a negative y value. So I can say that these are all negative. All the output values are negative. Now, we want to pick a number between negative 6 and negative 1, an x value between that. So like negative 4, okay? And let's just plug it in. So that's going to give us negative 4 times negative 4 plus 6 times negative 4 plus 1. Press enter, and I get 24. So that's positive. So that means all x values between negative 6 and negative 1 create positive y values. Alright, now we need to pick a number between negative 1 and 0, such as negative 0.5. Okay, and we're going to plug that guy in. So negative 0.5 times negative 0.5 plus 6 times negative 0.5 plus 1. Press enter. And we get negative. So that means all y values created by x values between negative 1 and 0 are negative. Okay, now we just need to choose a number to the right of 0, such as 1. Okay, we plug that in, it's going to be positive, 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 so that's going to be positive. Sorry about that. I'm too lazy to figure out how to edit those things out, so that's going to stay. Alright, so now look at what the answer wants. Less than 0. So those are negative values, right? So where were my negative y values being created by? What x intervals? This x interval and this x interval. So I have two intervals that create negative outputs. So negative infinity to negative 6. So parenthesis, and this gets a bracket because it's equal to. And negative 1 to 0. Negative 1 to 0. And those both get brackets. Okay? Let's go on to problem 16 now. Alright, 16 is exactly the same. You need to get your zeros, so you're going to have to factor first. So this guy factors to being x minus 8, x minus 4, okay, which is 8 and 4. So your zeros are 8 and 4. So I'm going to set that up on a number line. Y'all like how beautiful my my number line is there? So there's a 4, there's an 8. So we need to pick a number to the left of 4, such as 0. Plug it in, 0, 0. That gives me negative 8 times negative 4, which is a positive 32. So this is positive. Pick a number between 4. And again, guys, I did that in my head. Put it in a calculator. Alright? 4 to 8, such as 5. Plug it in. 5 minus 8, 5 minus 4. That's going to be negative. That's going to be positive. Negative times a positive is negative. No, Gabe, it does not necessarily switch each time, but I know each one of our problems so far have, but I guarantee you there are problems that do not. Okay? You just may never see one. Okay? So now let's do a number to the right of 8, such as 10. Alright? Plug it in. 10 minus 8, 10 minus 4, positive, positive. That makes positive. Okay? So now, what I'm looking at here is, my brain farted. Sorry about that. I need positive numbers. I need positive intervals because I want to be greater than or equal to 0. So this interval and this interval. So from negative infinity to 0, and it gets a bracket because it's equal to, and then from 8 to infinity. Alright. Let's go on to problem 17. Okay, problem 17 is a little bit of a jerk of a problem. Okay, let's be clear. This problem is just being a jerk to be a jerk. It's not hard to solve. You want this to be 0. Okay, we don't want to have to try to think about what numbers make it greater than 1. You don't want to do that. Just make this 0 by doing what? That's right, by subtracting 1. Now, it's going to be a little bit harder to figure out what are your x-intercepts, what are your zeros, because we have this minus 1 that's not a part of this guy. So what we're going to do to cheat to save ourselves some time is we're just going to plug it in a calculator. Okay? So we're going to go to y equals. We're just going to plug this in a calculator. So I didn't clear everything the way I thought I did. So 4 divided by x plus 6. This is going to be a pain. And I do not like this problem. Second, insert parenthesis. Your guys' calculators, you can just use that alpha y equals, create a fraction thing. This calculator cannot do that. Okay. So I know that I told you guys yesterday the problem with using calculators, you can't figure out where your asymptotes are located. And yes, that's true. You still cannot figure out where your asymptotes are located. But we can, maybe with a little more ease, figure out where our x-intercept is located. Because there is an x-intercept because this is not one big fraction. Okay. So second graph, we see that we have an x-intercept at negative 2. Okay. So that's nice. So that's a 0. So our 0 is at negative 2. Okay. And then my vertical asymptote is still just set the only denominator the denominator is not going to change. So set the only denominator we have equals 0. So that gives me x equals -6. So now I can create my number line. All right, my number line is -6 and -2. All right, so pick a number to the left of -6, such as -10. Okay, now this guy's a little bit more of a pain when doing this problem. All right, so what I'm going to do is I'm just going to say 4 divided by -10 plus 6, because that -1 can change things. So -1, that gave me a negative, not a big deal. Okay, pick a number between -6 and -2, such as -4. Alright, I'm going to plug that in. So let's go change this -10 to being a -4. Man, this is a long video. That's 1, so that's positive. And now I need to pick a number to the right of -2, such as 0. I plug that in, I'm going to get 4 over 6 minus 1. I know that's going to be negative. So that's negative. And we're only looking for positive intervals, so from -6 to -2, and it's equal to, so it also gets bracket, -6 to -2. So that gets a bracket. Alright, I told you guys not to worry about 18, and I mean it. Don't worry about it. Move on to problem 19. Find the maximum. Okay, this is actually a review problem from like the last 6 weeks. We just wanted to see how much you guys could remember. Alright? So you're going to go, or how much you retain, not how much you remember, but how much did you retain? Okay? So first off, we're going to plug it in. Now there is, I have a slight error with this. I have a slight frustration with this problem. Because technically this problem doesn't have a maximum, but it's talking, oh, you can't see it if you just type it in your calculator. Just hit zoom 0. It'll help. You might even have to play around with it a little bit after that. My issue with this problem is the fact that it's actually talking about finding the local maximum, not just a maximum. Right here they just say maximum. We have a local maximum happening something like right here, but it's really, really hard to see. Alright? So what I like to do is I hit zoom 0. That's zoom fit. Okay? But I still can't see it all that great. So what I'm going to do instead is I'm going to go back to zoom 6. I'm still not going to be able to see it. And then, I didn't mean to do that. I wanted to go back to zoom fit. I'm so sorry, guys. Oh, this is already a long video and I'm over here bumbling around like a moron. Alright, so I'm back at zoom 0. But you should realize that your local maximum is happening to the right here. It's somewhere over here. So that means, do I really care about all these x values? Are these going to be a maximum somehow? No, these are useless. So I'm going to go to my window, and I'm going to change it from being an x min of -10 to being an x min at 0. And I'm going to change my x max to being something like 15. I'm going to hit graph, and I'm going to see what that makes it look like. So now you can tell that I have a maximum happening somewhere in here. So I can hit second trace. I can go down to maximum. And it's going to say left bound. So you just need to move your cursor, which is you probably at the very top of your calculator. That's where mine was anyway. Do you guys see my cursor right there? It's kind of hard to see, but it's right there. You know the maximum's going to be somewhere up here. So press enter, right bound. Now I just need to move until I'm somewhere confidently to the right of where the maximum would be. At this point in time, I can say the maximum is probably happening somewhere right here. So I'll press enter. I press enter again. So my maximum is at 6.674740. Okay, so 6.674740.74. Okay. So now I do that. Okay. Now look at question 20. It says, on what interval is function 19 increasing, decreasing? Okay. So now it's important that you remember what our graph looked like originally. So I'm going to hit zoom 0 again. Alright. Oh man, I didn't change my window back. Well, that's a now really pretty looking graph, isn't it? Okay, let's go back to zoom 6. And the reason I'm doing this is I want you guys to remember what the graph looked like originally. Now zoom 0. Okay, so the graph went up, 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 up. Then I hit a cap right here, and then I'm going to start going down, 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 down. And then actually you turn again, but we don't care about that. Okay, I can just tell you we're not going to care about that. Alright, so basically, guys, I increased from negative infinity up to my maximum, right? Which was 6.67. Because remember, intervals are x values. And then, what I do after my maximum? I started to go back down. So 6.67 to infinity. Alright, and that's all they're really looking for on those two questions. Guys, I know there's a lot of kind of newish stuff on this. Don't freak out about it. Just take your time. Review. Alright, I'm not going to lie to you and say this is an easy test. It's clearly not. This was a 35-minute review video. Alright, hit me up with Remind. Send me an email if you have questions. I won't be after school today, but I will try to get in early tomorrow. And in fact, if you watch the end of this video and you want to come in early, I'll say you can show up at about 8 and I'll let you in. Okay? And I'll answer any questions you have. Alright, you guys have a great day. I'll see you tomorrow for the test.